everyone, welcome to Maths Easy. Here's another popular A-level physics exam question on momentum. Please pause the video and give it a try. When you are ready for the answer, press play and then you can check your answer against mine. A spacecraft with mass 2000 kg is moving through deep space at a constant speed of 10 meters per second relative to a fixed point. It suddenly explodes into two pieces. One piece has a mass 500 kilograms. It flies backwards at 30 relative to the spacecraft's original direction of motion, so it's opposite to that. The second piece is the remaining part of the spacecraft, which obviously tells us 2000 kilograms is the total mass. 500 kilograms is one piece, so the remaining piece must be 1500 kilograms. The second piece is the remaining part. Calculate the speed of the second piece relative to the fixed point in space. Now, we are going to write the conservation of momentum to the right. Because there is no external forces acting on it, the initial momentum is equal to final momentum, and we are writing it to the right. Now, the initial momentum is just 2000 multiplied by 10. The final momentum, now it's really important we are writing it to the right, but this 500 kilogram is going to the left. So that's a negative value. 500 multiplied by 30. The other one is obviously going to the same direction. So 1500 V. So 2000 times 10, 20,000. Add 500 times 30 is 15,000 is equal to 1500 V, and we can simplify to get the value of V. So the answer is 23.3 meters per second. Second part, work out how much kinetic energy the system gained during the explosion. So for this one, we need to find the initial kinetic energy. So the kinetic energy initial is half times 2000 times 10 squared, which is 100,000 joules. Now this is the initial kinetic energy. Let's get the final kinetic energy. Now energy is a scalar, so there's no direction to it. I can just add up the kinetic energy. So kinetic energy final is half times 500 times 30 squared. That is for the first piece. Add half times 1500 times 23.3 squared. 633,333 joules. So we can see it started with 100,000 joules. The explosion increased the kinetic energy to 633,333. How much kinetic energy the system gained? 533,000 joules is the answer.